Hello. We got a new camera. Thank you very much to Kurt here in Prescott who donated this camera to me. My original plan for it is to use it for photogrammetry, where I can take a very high resolution, or reasonably high, it's 16 megapixel image, and then I can take measurements from that and do CAD work and then create three-dimensional objects based on my photo measurement. So the camera actually does really well at video as well, so I thought I'd kind of step up my game on my videos and get some better editing and some higher quality footage. So what we're going to do is we are going to take this wheelchair motor, which in a previous video we removed the brake off of it and we 3D printed a little thing to go on the back of a motor shaft to hold our magnets, and this is a very inexpensive Hall effect sensor. So now we have a tachometer on the back of our wheelchair motor. We also determined our gear ratio is 32:1 in the gearbox, so that gives us a ton of torque. We're going to use the BTS 7960 motor controller. These are about $7. And a little micro hobby servo. I don't know what these cost, but I think they're around $1 or $2 if you buy a few at a time. So what we're going to do is we're going to disassemble the hobby servo. We're going to make a control arm that links the turn pot on the inside of the hobby servo to our main output shaft, and we're going to drive the motor with the BTS 7960. Our input control for testing may come from a simple little servo tester, or it may also come from an RC control, or we could send a signal with PWM from a microcontroller. So what's the point of all this? Well, who knows? You might need to have a really large, powerful servo, and there's kind of no end to what you might do with that. For this next part, we're going to disassemble our hobby servo. These are the little SG90s, Micro Servo SG90, very inexpensive. You probably want to take a knife and cut the label, because this case comes apart in 3 sections, and so you're going to want to remove the bottom section. If you have a horn on there, you probably want to take that off, and then you need a really tiny little screwdriver, and it's just for these little screws on the bottom here. Take all 4 of those out, and then the case will come apart at the top, but you don't really want to split it at the top. You'll see there's the gears there, at least not yet. What we want to do is take the bottom section off, and that exposes our motor and the circuit board in here. So you can kind of pull this out just a little bit and get some better access to it. And what we're going to want to do is unsolder the 2 wires off the back of the motor. We could just cut them too and restrip them, but to me it seems cleaner just to unsolder them. It'll leave the motor terminals clean if we want to use the motor for something else. So now we have our motor wires unsoldered off the back, and we're just going to take a needle nose pair of pliers or whatever and just gently pull this motor out. And it's a cute little motor, so let me know in the comments what we can do with some of these, because I have a feeling I'm going to be making more servos and this is just going to get repurposed, but it's an adorable little 5-volt motor, so I'm sure we can make something fun out of that. I've taken the top off so you can see the gears. Some people on some of the videos where I've watched them make a similar kind of a thing, you can see inside that is the backside of the variable resistor, turn pot, trim pot. There's lots of different words. Trim, it's not really a trim pot in this case, it's really a turn pot. It's a turn potentiometer. And that's what takes a measurement on the position that the shaft is in of our servo. So that's what's going to give us our feedback here. So what some people will do, they'll take some of the gears off and they'll actually drive that turn pot through a gear train on the motor itself. And that's a great way to do it, and I may do something like that in the future. But what I'm going to do is I'm going to put it back together again, and all I'm going to do is make a slight little notch for these motor wires to come out the side, and I'm going to put the bottom back on, and we're going to seal it all back up. We now have our 4 screws back in on the back of the case. That keeps it all together again, and you can see I just took my side cutters and I just cut a tiny little notch before I put the 2 halves or the 3 halves together, but in this section I just took out a little nip right there on each side, and that allows the motor wires to come out. Gives us kind of the most length on those wires that we have to play with now. And This is also a good time to, once you've got the case assembled, figure out where your center position is on the servo. And you can do that just by moving it back and forth, and with no motor in there it actually turns pretty easily. So you can see it's going just a little past 180 degrees each time I do that. And what I did is I just took off the horn and I put it on a different notch so that I got it so it was fairly simple to then, once I figured out the full travel, now I know that if I go about here, 90 degrees, that's pretty much the center position. It'll go half this way and half this way. So that's going to be important later, because when we connect it to our motor, we're going to want to make sure we know where we are in our position. In other words, if we were all the way to this side and the first thing we did was drive our motor this way, we could break our little servo. So we kind of want to know where we are as far as centered. And I'm also going to recommend, when we make our connecting rod that goes from this tiny hobby servo horn to our big horn, we figure out our geometry fairly carefully first and make that connecting rod something that if it does overextend, it's not going to trash our servo. Maybe the connecting rod will just bend or come off or something like that. So we'll address that in a little bit. Okay, sidetrack. This is just 5 volts from our 5-volt power supply, and just powering this motor. A little bit of hot glue, using the glue gun my beautiful wife gave me. One of my favorite tools in the shop. We're just adding a little strain relief to these motor wires, and we might as well do the actual signal and power wires too that are here. Just give them a little extra strain relief. That just keeps everything happy. So the next thing we're going to do is we want to lengthen our motor wires, and I'm going to stop calling them motor wires because they're really not anymore. They were the output from the servo to our tiny little motor. But what they're going to do now is they're actually going to feed the logic pins of our bigger motor driver. And since they output a PWM, which was for a tiny motor, we can just use the PWM, which is pulse width modulation, and go straight into this controller. And the way the controller has been set up by the manufacturer is that it will take the input from the hobby servo as its logic input to drive the motor with the MOSFETs here. So without any microcontroller at all, we're going to have some pretty precision motor control. So I'm just going to take one of these DuPont style connectors. This happens to be just 2 of them stuck together. These are the female, very common, very inexpensive. If you've tinkered with microcontrollers and electronics, you've probably got some of this stuff around. I'm going to cut this one about in half because I have a feeling I'm going to be making another one of these giant servos pretty soon. So I'm going to save that half, and we're going to probably make another one of these shortly. But I'm just going to strip them back, and I'll do that off camera. We're all set up with our helping hands, and we're ready to solder this up. And I'm going to go ahead and do that off camera. Okay, now we've finished up the soldering with our shrink tubing on there. And so we now have our PWM wires that are going to feed into our controller. The one thing we haven't talked about yet is how we're going to power that controller. And I'm mentioning it now because it takes 5 volts. And so some of the pins on here, or 2 of the pins, there's going to be a ground and a 5-volt input. We're also going to pull one of the other pins high using a 5-volt. And I'll explain more about that when we get to the wiring. Depending on what is going to be actually running your servo, whether it be an RC radio or a servo tester or a microcontroller or something else that's generating a hobby style PWM output, if you've got 5 volts around that's going to be powering that device, we can power our motor controller with the same 5 volts. But if you don't have any other supply, or if it's just easier, now would be a time you could tap into the wires here and pull a 5 volts, because 2 of the lines that feed a servo, one of them signal, but one is ground and the other is 5 volts. So you could tie in there in preparation for how we're going to supply our controller. In my case, I'm going to use the benchtop power supply until I know where I'm actually going to install this, and at that point in time I'll figure out what the best 5-volt source is to run this. It's probably going to be a microcontroller, but who knows. Anyway, that's just something to think about at this point in time, so we're ready to move on to the next step. Now we're putting our last DuPont connector, which is a ground wire, onto the ground rail of our breadboard. So here's our wiring. This comes from our benchtop power supply. It's 5 volts. Later on, this would be something else in the field, a battery or whatever's running your receiver. We simply have the positive 5 volts in the ground from the power supply to our power rail. We also have 5 volts in ground going to our little servo tester here. We have the 2 wires coming from both from positive here, and you could use red for these wires. I chose green and blue. They are going to the left and right enable pins on our motor controller. And the reason I used blue and green, because they're basically now acting as a signal wire or control logic. We're sending these pins, the left and right enable pins, high with 5 volts. In our case, it's simply coming right off of our power supply here. So they could be red or blue or green. It's your choice, but I'm choosing to look at them as signal wires from here on. This wire here is doing nothing other than holding our little Hobby Servo kind of down in place. The wiring has no relevance whatsoever. And the last bit is just the standard Hobby Servo connection with the signal plus 5 volts and ground going into our little servo tester here. So that should give us the layout. The only thing that's not hooked up yet, we have the high voltage. Our big wires to the motor are going to the motor control output on our motor controller here. And at the moment we haven't paid any attention to polarity. If we find something's going the wrong direction, we'll just simply switch the polarity around. The last thing we need to do to actually test this will be to give our motor a supply, and we've got a 24 volt power supply over on the workbench here that we're going to supply our 24 volts with. And then without doing any linkage connection, we're just simply going to give an input on our tester here. It's going to make the motor move until we put this in the position that it expects to be, and then the motor would theoretically stop until we enter some more control signals again. So we're going to test this all out kind of on a breadboard before we connect our horn up and link it all together. This project is under development right now. This is not a tutorial. This is not something I've done. I'm not trying to show you how to do something. I'm just exploring how I'm doing something and hoping that you can benefit from it. We've been wiring and putting things on the breadboard. We've had a second helper here, and that's our robotic friend, which is our 3D printer. I say that somewhat jokingly, our robotic friend, but it's actually quite amazing when you think about it, because it's like having 2 people working at once. The machine is over here producing our part, and we've been wiring and doing other things at the same time. So you'll probably recognize what's on the printer bed here, and it is a very large horn for the servo that's going to go on our motor. I'm 3D printing this. If you don't have access to a 3D printer, that's fine. You don't need to. You could easily sketch something out on a piece of cardboard and trace it onto wood. You could cut it out of metal, either aluminum with a hacksaw, or you could use a torch and cut one out of steel. I mean, there's all kinds of ways you can make stuff like this. At some point, I'd like to get this laser cut or maybe plasma cut out of some plate stock of steel, and then I'd weld a collar onto it so we could clamp it tightly onto the motor shaft. But for now, we're just going to test with a 3D printed plastic one. We're ready for our first test. Well, actually not. I did an initial first test off camera. If you've been watching closely, you may have noticed that I have changed the motor controllers. This is the one I used for my very first test, and this is the one I just put in its place. On my very first test, I used this one because this one has one of its MOSFETs is blown, and that happened on another project of mine. That's the 6-wheel drive Mars-style robot, and it uses 6 of these motors to drive the mechanisms. And in some of my earlier testing, I ended up blowing half of one of these controllers, which means it only works in one direction. And that may still be useful. I probably got something that I want to control a motor that doesn't need to reverse. It just needs to spin in one direction at some said speed. So even though it's half blown, it's still good to me. But because I had that one for my first setup, I thought, well, I might as well use one that's already got some damage to it, just in case I screw something up. Fortunately, I didn't. It still works just as it did. Here's a brand new one I just took out of the package. So I'll just quickly go over the wiring again. This power supply here to our board is being fed from our benchtop power supply. That's currently 24 volts. The output goes to the motor. Its PWM left and right channels are being fed from the output of this servo, which used to be the motor output. The input is just going to a simple servo tester here, and we also are giving 5 volts to the 2 left and right enable pins, and then we have a ground to the system. It's pretty straightforward wiring. I'll try to get an actual diagram posted. But what you can see is happening now, if we make an adjustment on our servo tester here, you see the motor starts moving. Now it's going to spin continuously in this setup because we don't have our linkage between our input here. But you'll see if we change our input a little bit, we've moved it, now this motor has stopped. That would basically mean it's got to the position that our signal has said it should go to. So we can do it again. I can also turn the knob the other way. You can see this would be a movement in the other direction. So if we move this until we get to that spot, it will stop. And you see I've overshot a little bit, but you can fine tune your servo here as well. So it's proof of concept. Now we just got to make sure our geometry works so that when this motor shaft moves the right amount, it will not break off any of our servo stuff. But it's working. You can see this is the proof of the concept. Now I think we're ready to do a prototype with the glue gun and experiment with how this might actually work. Give it a little bit more of a wiring and some linkage. We now have our oversized horn that came off the 3D printer. It fit pretty well on the shaft. I just did a little bit of filing and I'm happy with that. We've also hot glued our servo to the case of the motor, and we just fashioned up a little connecting rod out of some wire I had. Now, I could have taken the time to calculate all the geometry that was required here in CAD, but I chose not to. I'm kind of wanting to do this project more build on the fly, obviously with the exception of this 3D printed part. So I'm going to turn it on for the first time this time, no cheating, and it may tear the servo off, it may do something weird, I don't know. It's hot glued only to this case, which the glue will probably release if it pulls too hard. I'm also realizing that this little connecting rod may conflict with the shaft here because the shaft is so thick. Basically what I did is I spaced out the distance between the center point of the rotation of the servo horn here. The distance to where the connecting rod connects to the servo is roughly the same distance from the center of this shaft to out here. So it should work more or less in parallel, but because of the thickness of this shaft, the connecting rod may contact the shaft. So we may have to extend our horn, maybe come this direction and have a little bit more wiggle room so that our motion doesn't conflict with the shaft. But I'm going to turn it on for the first time and we'll just see what happens. Okay, so far so good. It's basically holding in more or less the center position, which was my goal. I put my servo tester in more or less the center position. My servo is basically in the center position, and I lined up the motor shaft in this orientation. Now I'm going to adjust the knob just a little bit and see what happens. Okay, it is moving in that direction under our control. I'm going to come back the other way. And it seems to move back the other direction adequately. A little further in this direction. We need to steady this motor, it's a beast. So that seems to be working. Alright, well, hooray for first tests. It actually seemed to work. Oh, and now something broke off. Haha. Okay. We've now got 4 layers of shrink tube on the end of our servo horn here, and provides maybe a reasonable extension. It does have some flexibility. It's still a bit warm, but when it cools off that should stiffen up and may give us just enough flexibility for some wiggle room, but without getting a bunch of slop in the system. So I don't recommend this for everybody, but it's a fast way of putting a hole in plastic parts. If you're not comfortable with a torch, just get out a small drill, but this is very fast way to make holes and stuff, plastic anyway. Here's our next experiment on our linkage. I used shrink tube to extend the length of the Hobby Servo arm. I fashioned just another little connecting rod that seems to be about the right position. Basically I tried to make the distance from the center of the big motor shaft the same distance as the center of the Hobby Servo as far as the connecting rod. Right now it doesn't look quite parallel. There may be some geometry going on there, but I think for a mock-up test we'll have a good idea if this is going to work or not. It didn't go flying off in either direction, so that's a good sign. We should be more or less centered here. I'm going to experiment with our servo tester. Maybe I'll hold the motor a little bit more steady. Okay, so rotating the servo tester knob seems to do what we want. I'm just jogging the knob back and forth. I know you can't see my fingers, but that's what I'm doing with the knob here. It's just kind of going back and forth. But it seems to be taking input from our servo tester and driving our big motor as we expect. As you noticed, I'm sort of staying away from the far edges or the full range of travel, but let's find out what happens if I go to one side, fairly extreme. This is where I expect we may have an issue with the extended horn of our input servo here. I guess we can call this the input servo now, our shaft position sensor is really what it's doing at this moment, and also converting our PWM from hobby signal into a PWM input for our big motor controller. So it's kind of doing two things at once. So if I go too much further, I see what's going to happen. We're going to run out of travel here, where the connecting rod will be fully extended. Our extension here is going to hit the motor shaft, and then of course it's going to try to bend it around the corner. I'm going to go a little further just to see what happens, but I think we need to have some limits or change our mechanics a little bit more so that we don't have a conflict. Right now it could break itself apart if I keep going any further. Okay, but we are at the full extent of the travel. I've turned the servo tester knob all the way to the end, and at full travel it looks like we are just almost in conflict, but we're not, so that's a good sign. So the electronics stop before the mechanics self-destruct. That's always a good design concept. Come back the other way. Let's see what happens if we go to full extension the other direction. Our connecting rod should just swing underneath. I heard something kind of gnarly. Did we break our servo off? No? There's some conflict underneath. Yeah, so it partly broke our servo off, so the geometry still isn't quite right. On this full reach, it's sort of unstuck our hot glue here. But I think we're on to something. That's basically what I had in mind it would do. So what I've done now is mounted the servo, our hobby servo, on top of the shaft. Two shafts of the hobby servo and our motor are now concentric. So in some ways this is a much better arrangement because the two shafts, they rotate on the same axis. And there's a lot to be said for that. What I don't like now is we've got our servo kind of stacked up here. Obviously, at the moment, just for testing, I've got a zip tie tail, and I've just simply glued the hobby servo to the zip tie tail, and it's zip tied to our electrical wires for stabilization. Horn is actually attached to the motor shaft, so it needs to rotate, but we need to hold the body of our hobby servo in a fixed position. I'm not crazy about it, and I know what you're thinking. This is quite a hokey arrangement here, and I agree. I would not argue that at all. But it is working. Servo tester here. Oh, and it's broken free. Ah, disaster! Alright, I've come up with a solution that I think might work. It's still prototype. I've got a double linkage now. I made sure to put the hobby servo in line with our motor shaft. I also changed it so that the keyway and our large horn, its center position is out this way now. The reason for that is because you'll see in a second when I start moving it, we're able to translate a little bit less motion to the motor compared to how much our hobby servo horn is moving. What that means is that we don't have as much travel as the original hobby servo, but we have a whole lot less problems with our linkage. And since I don't have an application for this yet, I don't know if this is going to be a correct orientation. For example, here's the 6 mounting bolts that would normally mount this wheelchair motor to a frame. So if the horn is not in the correct direction for whatever our application is, we may have an issue. I may need to put maybe 4 keyways in the horn so that it would at least have 4 different mounting positions. Ideal would be more like a spline where you had maybe 8 different mounting positions, something like that, or different kinds of horns. There were crosses and things like that. Just depends on what I was actually going to do with this as to what kind of horn I would put on it. Same like with hobby servo stuff, you have different horns depending on what you're doing. So let me just give you a demonstration now and hold the motor somewhat steady. And so now it's maxed out. I've got the hobby servo tester all the way to one side, and you can see that it's close. Maybe you can't quite see, but the linkage is not binding with the shaft here. This one is completely free. And then if we come the other way, it's the same thing on the other side, but you'll see that we don't have any binding. We're not ripping our servo off the top. This is still just hot glued for the moment, but we've got pretty reasonable control now of the motor. Whatever position I put the dial in, it goes to. I'm just wiggling it back and forth, moving it, letting go, move it, let go, move it, let go. So it's finding what position it needs to be in according to the potentiometer inside of our hobby servo. So I'm going to say this layout may be proof of concept. It's pretty kludgy still. Obviously we've got motor controllers that are just hanging by wires and a breadboard. This might be a configuration that might be workable. We'll need some sort of better mounting plate than hot glue, although sometimes that can hold pretty well for a reasonable amount of testing. I need to point out that in all of my testing, every time I move the servo, the Hobby Servo, around to a different configuration, especially when I put it concentric with the motor shaft on top, I always made sure that these wires here were in the correct order. Earlier in the video I said it really didn't matter. If we had an issue we could turn them around. Well, the problem is if you don't pay attention and they're the wrong way for what the servo input is expecting, it'll try to move the motor to one direction, and of course it'll never achieve the position it's trying to find because they're backwards. It's basically going the wrong way. Be careful. What I did is I just pulsed my power supply just gently to make sure it was going the right direction. It's real easy to get your mind kind of confused as to what direction is the correct direction, and sometimes you think you know, but you've moved something around, you flipped something upside down or 180 degrees from its previous position. So what I've been doing is checking carefully each time so I didn't just turn on the power supply and tear everything to pieces because it was going the wrong direction, and that's what it will do if you do have it backwards. It will mechanically destroy itself trying to find a position on the turn pot that it can't ever get to because it's going the wrong way. It's just these two wires here. These are the ones that lead from the what used to be the motor on the Hobby Servo, and they go to the L and the R PWM pins on our motor controller. So just a word of caution, make sure you've got those correct. If you've made it through the video this far, I appreciate you. Thank you for following along and watching my design process. What you've probably been waiting for to see what this thing can actually do, and of course I have been excited about that too. I currently have a 5-pound dumbbell hanging off the end of the horn, and that would be about 2¼ kilograms. The distance is about 4 3/4 inches, and that's about 120 millimeters or so. Based on that, we can calculate what our torque is, and I'll probably do that and have that information in the description. I'm going to stop at 5 pounds. I do have a 10-pounder here. I was tempted to try it. I have a feeling I'm just going to rip the plastic apart until we have something more permanent. I'm not going to try 10 pounds, but 5 pounds works just fine. Oops, my wire fell off. 5 pounds works just fine. But 5 pounds seems to be doing something weird, and I'm not sure what. The motor seems to have the torque. Based on my calculations, this is about 4.75 inches, 5 pounds. We're getting about 2 foot-pounds of torque. That's about 2.7 Newton meters. And every now and then I do get a stutter when I try to drive the servo too quickly. It seems to not be able to catch up to the position it wants to be in without a little bit of what looks like slippage, but I think it's the motor controller or the motor itself not being able to kind of keep up with the pulse rate. There's some PID tuning that could be done, but of course I'm using the PID that is just meant for a tiny little motor, and we're trying to drive something much bigger we're trying to drive a bigger motor with a PID that was set up for a very tiny servo. The logic hasn't changed from what we're trying to do here. We just have a lot more amperage going to it. So anyway, in conclusion, I think I'm going to call this video a wrap. I'm happy with it. Clearly it takes more. Oh, there you can see it's kind of stalling out right now. It was kind of stalling out right there for a minute based on the position that I had the servo tester in. I found that if I turn it too fast, it has a hard time keeping up, whereas if I move it slowly, it actually can keep up better. So probably pushing the limits of the system with a 5-pound weight on there. But that's a fair amount of torque. I mean, if we had a metal arm on here, there's no reason we couldn't turn the steering wheel of a go-kart, or we could move some sort of robot arm or an attachment on a snowplow or something. A small snowplow, you know, a robot-sized snowplow. Things like that. I also have in mind to have solar tracking system on my solar panels. This is probably a good little setup. And you may ask, why we go through all this trouble? Well, here we've got a recycled motor, big giant motor, and we've got a Hobby Servo. So what's the point of that? Well, now that we've got a standard Hobby Servo control input, and again, I'm going to pull it off my breadboard just to show you what this is again. It's so easy to now control because there's tons of sketches out there for Arduino. There's Python script that you can use in a microcontroller situation. Now that we've got just standard hobby style PWM input right here, on this one little signal wire, there's no end to what we can do with it. And there's so much code and examples available for us that now we can do all kinds of things with a giant servo motor. So it's just fun. I hope you enjoyed. It won't work anymore because I pulled it off my breadboard, so we no longer have power. But I'm going to disassemble it, make some improvements to some of the mechanics, maybe 3D print a better part to hold all this instead of hot glue. This is all just prototyping and testing. But thank you for watching. I appreciate it, and have a wonderful time playing with your projects, or working with your projects, or maybe we should say doing research and development. You'll see me later. Bye. I couldn't resist. I had to get out my fly sky, hooked up the receiver instead of the servo tester to our giant servo, and now using my transmitter to control the servo. My stick here returns to center with the spring, so does the servo. You'll see me later.